Hi and welcome to John's Maths book. In this video, I'm going to be looking at evaluating the indefinite integral of tan2Θdθ. If you like the video, then please hit the like button and I'd be delighted and honoured if you'd subscribe to the channel. Without further ado, let's go over to the whiteboard. Let's look at how we find the indefinite integral of tan2Θdθ. To evaluate this, we need to use a trig identity to replace tan2ϴ with something that we can more easily integrate, and then use integration by substitution to arrive at the final solution. Let's first replace tan2ϴ with a trig identity where tan2ϴ is equal to sin2ϴ divided by cos2ϴ. We're then left with the integral of sin2ϴ divided by cos2ϴ dθ. We can now use integration by substitution to evaluate this integral. So let's begin by letting u equal cos2ϴ. du by dθ will equal minus 2 multiplied by sin2ϴ, and it follows therefore that dθ will equal minus du over 2 multiplied by sin2ϴ. If we now replace u and cos2ϴ in the original expression, we're left with the integral of sin2ϴ divided by u, which replaces cos2ϴ, multiplied by, and then replacing dθ, we have negative du divided by 2 multiplied by sin2ϴ. Sine of 2ϴ in the numerator and the denominator cancel out, and we're left with minus a half multiplied by the integral of 1 divided by u du. The integral of 1 divided by u is the log of the absolute value of u. We multiply this by minus a half and we add a constant of integration. If we now substitute back in for u, where u is equal to cos2ϴ, we have a final answer which is minus 1/2 multiplied by the log of the absolute value of cos2ϴ plus a constant of integration.